to the 2014 summer examination for 6G4Z3002, and these are the linear algebra solutions. So question number 1 is on matrices and vectors. So for part A, we just have to multiply matrices, find a cofactor, and solve a system of simultaneous equations using matrices. And then for part B, we have some simple vector algebra. So for part A, we have matrix B is a 3 by 3 and matrix C is a 3 by 1. Is it possible to determine B times C? Well, the number of columns of the first matrix is 3 is equal to the number of rows of the second matrix C, so this is possible. So to find the element in row 1, column 1, we multiply row 1 by column 1. So we get minus 4 plus 0 plus 6. And minus 4 plus 6 gives you 2. To find the element in row 2, column 1, we multiply row 2 by column 1. So we get minus 5 plus 2 plus 3 gives you 0. And finally, to find the element in row 3, column 1, we multiply row 3 by column 1. So we have minus 3 plus 4 plus 3, which gives you 4. We want to find a cofactor of 5 in B. So here is the element 5 is in row 2, column 1. So 2 plus 1 is 3, so minus 1 to the power 3 gives you minus 1, so that's why there's a minus 1 there. And then we simply find the determinant when you delete row 2 and column 1, so that gives us the determinant 0, 2 and 2, 1. And if you work this out, you get 4. To solve for x, so here's our matrix B times x is equal to C. In this case, we use row reduction. So you can see here we row reduce, and we get down to this final row here. So z is equal to minus 11 over 10. Then we back substitute to find y, and then we back substitute to find x. So this is the solution. For part B, to determine 3 times the vector A minus 7 times the vector B, we simply multiply these elements, each of these elements by 3, and then we multiply each elements by 7. And then so for example, to get the first element, we multiply 12, take away 7 times 0 would give you 12. And you find the corresponding elements in the same way. To find A dot B, multiply the first element by the first element to give 0. And then you add and multiply the second element times the second element to give minus 10. And then we do the third element times the third element gives us 0. So overall, A dot B is just the scalar minus 10. To find the length of B, so to find the length of the vector B, we just look for the Euclidean norm. So we have the square root of the I vector plus the square of the j vector plus the square root of the k vector, and then we square root the whole answer, so you get root 13. And then determine a unit vector perpendicular to A and B. Well, if we take A crossed with B, so this gives us, so here's the element, the vector A, here is the vector B. We find this determinant to give us another vector, minus 15i plus 12j minus 8k. To find a unit vector, we simply divide this vector by its length, which in this case is root 433. And remember, we can negate this vector to get these, so we can negate this vector, and both of these vectors are normal to A and B. And that concludes the solutions to question number 1.